Okay, this is going to be Solidworks CSWA practice problem 2.6, and it's going to go in the Solidworks CSWA practice problems playlist. And if you want to follow along while I model this, you can follow the link that I put in the description. That's going to link you to the official Solidworks practice problem database. And so let's get started. So first of all, we're going to set our units, metric MMGS. Then we'll start a sketch of the base profile in the front plane. Now the origin is centered at the bottom left corner. So first we'll draw a line like this, line like this. Then we'll draw a horizontal line. And we'll just start there. We'll dimension them one at a time. Horizontal line is 142 millimeters. The angle of the line for the horizontal is going to be 58 degrees. And the length of this line is going to be 150. And as for the other line, it's also an angled line. And its dimension for the horizontal is going to be 108 degrees. And its length is going to be 150 as well. And the reason we did it in this order was because the line at the top, we were not given its angle or its length, so you had to find its two endpoints instead via these two lines. So you just connect them. And last but not least, you add a fillet, sketch fillet of radius 32 degrees to this corner. Select OK. There's your base profile. Now we're going to extrude this by 8. And now for the interesting part, which is the cuts. So start a sketch on the front face. And let's start with the thermostat cut. We'll draw a center line, diagonal center line. Now, just like before, this is a line where we don't know what angle it is with the horizontal, and we also don't know what length it is. But the one thing we do know is the endpoint dimensions with respect to the horizontal line. So this endpoint to this horizontal line is going to be 71. I'm trying to... Oh, wait, sorry. This endpoint to the origin is 71. And then this endpoint from this corner point is 82. So there's a center line you need. And I believe the thermostat is actually symmetric, so we can use that to our advantage. But we'll start with the circle at the top. Go like this. We will... The distance from this point to the center point is going to be 41. And it says the radius of the arc that this circle is going to make is 17. So we multiply that by 2, and we get 34. So the diameter is 34. And then we will create another circle that will represent the end of the thermostat cut. And its radius that it's going to create is 7, so multiply that by 2. Its diameter has to be 14. And the distance along this center line between these two center points, let me see if I can, oh, there you go. You kind of need to drag the dimension a little bit to get it to be parallel with the center line. The distance between them is 55. Now, then we're going to have a line into an arc. Oh, let's just do tangent arc, tangent with the line, then connect it with the circle, and then we will add tangent relations between arc and circle. And then there's already tangent relations between arc and then line in this circle. And this arc is going to be of radius 8. And from the drawing, it's pretty clear that this straight line is meant to be parallel with the center line we created. So we're going to add a parallel relation. That's fully defined. And again, since I said it's symmetric earlier, we can use mirror entities for the arc and the line. We will mirror it about the center line. And there we go. Check OK. That looks good. Yes, that's correct. Okay. And then we'll use trim entities to make it all one shape. Do this, and now it's one cut. Okay. Now we can move on to the slot. So for when you're placing the slot, you're going to place both first the leftmost center point, and then the rightmost center point, and then a random point on its circumference. So we'll do that. But we'll make sure that the center points are coincident with the bottom edge. And from here, we'll add a bunch of relations. So the distance from origin to leftmost center point is going to be 47. And then the distance between the center points is going to be 52. And then the distance from the bottom edge to the top edge of the slot is going to be 9. And that should be the entire slot cut, I believe. Yes, that's it. Okay. So now we have 2 cuts. Now we can go to features, extrude cut, and we will just say through all. Select OK. Now we will check our answer. We have a volume of, I believe that's 1,096. Oh wait, sorry. Oh no, that 109,681 cubic millimeters, which is the answer, as can be seen by the solution. Hope you learned something from this video, and I'll see you in the next one.